I have a really great and exciting job. I'm a robot scientist and I engineer and build the next generation of robots. I really look at how what goes on with animals can influence and be used within robots to produce the next generation. And the reason we need that is because of this illusion here. If you have a look at this top square, you'll notice that it is brown. This square down the bottom here is clearly orange and much brighter. But if I remove this background very slowly so you can have a look at the squares remaining no change, you'll see that the squares now are quite obviously exactly the same. So when I put the background around the place, you can see that the bottom square appears to be brighter because it's surrounded by darker objects. And the top square appears to be darker because it's surrounded by lighter objects. But in reality, they are both exactly the same. This trick, this illusion that you see within your brain is actually quite useful. For anybody that's ever tried taking a photo of somebody standing in front of a bright light, you can see their face perfectly clearly, yet in the photo it'll be grey and washed out because the camera isn't able to see both the light and the dark parts at the same time that your eye could. And if we want to build robots that can function and see as well as we can, then we're going to have to learn from biology. Now, if I talk to you about robots that we have today, most of those are the industrial sized robots that we have in construction and manufacture. We have robots that can take very complicated parts from an assembly line and reconstruct things like cars, as long as the parts are in exactly the same place every time and the tasks that they have to do to those parts are exactly the same. If there's a small change within the system, the robots are not able to cope with that anymore. And that's because we have built systems that are so good at doing one thing, but only that one thing and only one way. So now we have robots that are really good at building complicated machines such as cars, but they can't do simple tasks like build sandwiches. The different components that make up a sandwich are not exactly the same every time. They're not located in exactly the same place relative to the robot every time, and so it's a much harder task for it to achieve. And if we want to have robots that can interact within the real world, they're going to have to do this. So as Charles Darwin said, it's not the strongest or the fastest or even the most intelligent that survives, but it's the one that's the most adaptable to change. So if we want to build robots that are adaptable to change, that can function within an environment rather than having to build an environment to house our robots, then we're going to have to learn from biology. So that's what I've been doing. I've been investigating flies and the way that flies are able to take off and to land and to move around, how they're able to function within their environment. They are so good at doing what they do, we call them flies for that purpose. And they are tiny. They are the size of your fingernail. Yet they can do all these miraculous tasks that none of our current robots are able to achieve anything close to. So by investigating the way that the fly brain works, I've been able to reconstruct models of how the fly brain works and put them into robotic systems. And these robotic systems are better able to travel around different areas without being confused by poor lighting conditions. They're able to do lots of complicated tasks like spot movement within a scene, and they're able to see dark, shadowy figures that are hidden using normal photography. So if we want to have a better world, where we can have our robots that interact with ourselves, then the key is to learn about ourselves and apply that into our robots.